We continue here part 1 of how to write correct net ionic equations from full formula reactions. The issue discussed is not often found in textbooks, and it is not done the same by everyone, but it is interesting. Now here's something that may have crossed your mind, or if it hasn't, it might blow your mind. If an ionic compound that is water-soluble is written as ions, and an ionic compound that is not water-soluble is not written as ions, what do we do with ionic compounds that are listed as slightly soluble or partly soluble, like barium hydroxide? My answer may surprise you. My answer is, it depends. What I do is to write the compound as ions if it is a reactant, but do not write it as ions if it is a product. Why? Because I feel this will most often represent what you will actually see, and the complete ionic equation is supposed to be the reality equation. Here's the logic for the first part. I'm showing you a reaction and a picture of it. Barium hydroxide is used as a reactant in this reaction. When you pick up the bottle of barium hydroxide to do the reaction, you will probably notice solid in the bottom of the bottle, since barium hydroxide isn't very soluble. It is probably what is called a saturated solution. It has as much dissolved as is possible. But when you are told to use 2 milliliters of the saturated barium hydroxide solution, you rightly assume that you are supposed to take the liquid part. So it contains the part of the barium hydroxide that has dissolved. It is the part that has ionized. This is the test tube on the left in my pictures. Therefore, I write barium hydroxide as ions when it is a reactant. That this tube does contain barium ions can be seen when a clear solution of sodium carbonate, which is not shown, is added. A precipitate of the insoluble barium carbonate is formed. That's the picture on the right. You see the full formula equation on the top here and the complete ionic equation with the precipitate, barium carbonate, on the bottom. Now for the second part of the logic. I write it not as ions if it is a product. Why? Because since the compound is less soluble than the usual soluble ionic compounds, there's a good chance that a precipitate will be observed, even if it is not in as large an amount as seen with insoluble compounds. Here's an example. We have barium nitrate and sodium hydroxide, which are both completely clear reactant solutions, and they are mixed to make a solution that looks like the picture in the tube underneath the word barium hydroxide. That test tube is hazy looking. It doesn't quite look like precipitate, but it doesn't look clear like the reactants did. After sitting a while, it looks like the tube in the picture on the right, the left-hand tube. There looks like a small amount of precipitate. I've included the tube from the reaction that formed barium carbonate next to it, so you can see that the amounts are substantially different, but in fact we did get some precipitate of barium hydroxide in the reaction shown. In both of these reactions, the same concentrations and same amounts of solutions were used. So I write barium hydroxide solid as a product in my equation. You can see the complete ionic equation at the bottom of the page.